Well, Tricia and Kelly talked about golden bead as it applies to addition. And then, of course, then I'm going to skip ahead a little bit because they're going to work with that in subtraction as well. And then they're going to go on to a beautiful work called checkerboard to do multiplication. And that's where some of those little handy-dandy colored bead bars come in handy. But I'm going to kind of skip forward to my world in Upper L. And this is a beautiful work called the test tube, and it's how they learn long division. Right before test tube long division, they have learned golden bead division and then stamp game division, and then they finally moved to this to learn the logarithm, so it's even more abstract. A really cool thing is, and she was talking about the families, here's the families. Units, tens, hundreds, unit thousands, 10,000s, 100,000s, and millions. So you still have the same family thing that they're used to, and the green, blue, and red. So they work quite a bit with division, and then they move themselves on to decimal work. And the big deal in Upper L is that they've been working with whole numbers up till now, and now we get into tinier numbers, decimal fractions. So they learn how to take a unit and divide it up into 10 tenths, 100 hundredths, 1,000 thousandths, 10,000 10,000ths, 100,000 100,000ths, and then very tiny millionths. So we talk about that that's a really great thing for scientists and engineers to learn, is little tiny numbers. And it really strikes their imagination because big kids love to think big and abstract and crazy, and they love puzzles. So we really work a lot with decimals. This is a beautiful decimal candelabra. It's more of a kind of, oh Lord, it's backwards. No, it's good. It's good. I'm like, oh my God, I messed up for a minute. But that's just a beautiful work. When they learn how to form decimals back in this world, they learned how to form regular whole numbers. When they learn how to form decimals and they get that down pat, then they get to do this beautiful candelabra work. And the unit is in the middle because everything revolves around that doggone unit. And so they light this together. It's really beautiful work. So throughout there, they're learning that decimals help us with percentages and ratios and proportions. There's tons of work. That's the bulk of our work, is the decimal curriculum. And there's a lot of abstraction in there, but they move themselves on. I don't know if you guys can see this. This is a beautiful work, the decimal checkerboard. Back in Lower L, they do the checkerboard with whole numbers, and it's multiplying multiplier times a multiplicand to get a product. And this is the decimal times the decimal, so it's pretty cool. I still see that, the patterns, like Lori was talking about with the patterns. Somewhere in there, we introduce algebraic stuff. You guys have some really cool trinomial and binomial cubes. But before we get there, we're still doing lots of patterns. I don't have room to set all this out, but you guys are welcome to look at it in a little bit. They learn binomials and trinomials and what it looks like when you multiply a binomial times a binomial and the very distinct patterns that you get. From there, they go into squaring, which harkens back to those little squares. And then they learn square rooting, which I'm going to show you square rooting, and it's pretty cool. And it's with a golden bead. Before we start square rooting, we talk about etymology, because we're all into etymology and where a word comes from. And the word root, square root, or actually, it comes from the Latin word radix, which means radish. So the part in here, the stuff that you start with, is called the radicand. And the sign out here is called the radical. And this is called the root, which is radix, which I think is really cool. And so when we first start that lesson, I gave Kaylee that this summer, they got to cut up radishes and talk about the etymology of where this comes from. So they really dig that. So we're going to start with our radicand of 625. 625. Now they've worked a lot with these patterns, and you guys didn't get to see this because it's on a pegboard, and this is a binomial. And they know that since the radicand is 3 digits, the root is going to be a binomial. It's going to be 2 digits. They just know that. You guys don't know that, but they do. And it's going to look like that. And if you know, and this pattern is so ingrained in them that they're just like, oh yeah, I got it. It's a binomial. So we're going to build a square, the largest square that we can, with the hundreds. And the largest square that I can make with 600 is 400. Everybody get that? Everybody understand it? And I can't do much with these guys, so I have to exchange, and they're used to that because they've done it for years. So for each 100, I get 10 bars. And then I'm going to build these 2 rectangles out here. which, by the way, would be your AB term. Rectangle, rectangle, rectangle. And then I'm going to build that square off that rectangle. This may not mean much to you guys, but it totally does to them. Rectangle, 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 rectangle. And now I have a square of 4. Rectangle, rectangle. And I don't have enough, so I'm going to have to buy some. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I've got 3 bars out here. I'm going to have to build a 3 square. Is everybody following me? Yeah. Yeah, sort of, kind of. Rectangle, rectangle. Square of 4. I don't have enough, so I'm going to have to buy some more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 1, 2, 3, 4. Yep. 5. Oops, I didn't get enough. Oh, I did. That's perfect. And and the root is the bottom. The square root of 625 is 25. And the kids know that. Isn't that cool? Yeah. Ta-da! And like I said, they're like, oh, yeah, that's cool. They see it. You know, they've been working with it forever. From there, they would move to the pegboard, which is some more of this hierarchy color. The pegs are green, blue, and red, so they move right from that into this world. So they would build the they would build the Radicand with the pegs and build this out just like that. I can show you. The orange, no, it's just see, Lori was making fun of my golden bead set because it's not perfect primary material, but no, it doesn't mean anything. It's just a different manufacturer. We don't spend a lot of time on golden beads, so we just get this set. After they learn how to square root, they move on to cubing. And I completely forgot my beautiful cubing material, but I'll go down and get it. It corresponds really beautifully to the pink tower, except that it's the color of the bead frame. So it's gorgeous when I had 2 6th grade girls last year get all the way through it, and they were building these cubes, and they set it up, and they're like, oh, that's the pink tower. And they remembered it way from. But here's where our friends, the binomial and the trinomial cube, come back, and this is where they learn how to apply the algebraic nomenclature to it, which I think is super, super awesome. So let's see if I can do this without my cheater. So if you have like a cubed, okay, that's a cubed, or b cubed. So here's a cubed, and this goes back into that 3-dimensional, which, by the way, also corresponds to our geometry, because when they're squaring, that's like area. And when they're cubing, that's volume. So it's all kind of working alongside. So if this is a cubed, this is a squared b. See, because it's the same. It's 2 dimensions a, 1 dimension b. Does that make sense? And there are 3 of them. This is b cubed, b, b, b. And then it's b squared a, because it's 2 dimensions b, 1 dimension a. Does that make sense too? This would be a binomial times a binomial times a binomial. So, whoosh, I know, right? Yeah. But it is pretty cool when they start plugging in numbers. And then this is the formula for trinomial cubed, and you're just going to have to take my word for it and come up and play with it later, because there's a lot to it. When they talked about fact strands, when they're learning the facts or reiterating the facts, we do some practical math in our age group, and we do homework too. This is where we introduce big bad homework. And this is our Saxon book, and this would be the one for the 6th graders. And it just has some practical math. It has some different ways of doing things. It also gets them used to the world of textbooks, because unfortunately that's what they're going to get out there and get into. Also has a lot of problem solving and word problems like they've gotten in lower L. So I think that's all I have to say. I feel like I've blazed through our curriculum rather quickly. I will give it to you.